Hey, okay guys, I hope everyone is well. I am still great. So anyway, we're now looking at the next method. In this method, we're going to use elimination, right? So you can just note that down. We're going to be using elimination. Let me just reduce my pen size. That's okay. We're going to be using elimination. I'm sorry, no, we're going to be using equating. We're going to be using equating. So what equating does is that for both these equations, you make sure that they are in the same variable. So okay, let's go for this one. I'll write these equations. So I'll say y. So let me actually write that we're using where we have to equate, right? We're using that method. Anyway, so you're definitely gonna write that you have x plus 3y plus 5 is equal to 0, and that's your equation number 1. And then that's 3x plus 4 minus 2y, that's equation number 2. So your first step in this one is that you must express both. Number 1, it's express both equations with the same subject. That's not nice. With the same variable. What does that mean? It basically means that make this y is equal to something and make this y is equal to something. So basically you have y, you're going to try to, or maybe let me write this properly. You're going to say from equation number 1, right? So you're going to say, you're going to try to make y the subject. So if you in that form, if you say 3y is equal to minus x plus 5, you just have to divide by this 3 now to be okay. So you can, if you divide by that 3, you're gonna have negative 1 over, let me actually write this better than what I'm doing. I'll try to write it a bit better. So what you're gonna do is you're gonna say I want to divide by this 3 here, and I'm going to divide by 3 there, and I'm going to divide by 3. So you will have y negative 1 over 3x plus 5 over 3, right? And then what we're going to also do is we're going to say from, so we said both equations. So what we're going to also do, we're going to say from equation 2, we're going to say from equation 2, we're going to do the same thing. So we had 3x plus 4 minus 2y is equal to 0. So we're going to do the exact same thing, right? So we're going to say, actually, I just want to write this consistently. So the way I wrote it now, it's not cute. So what we're going to do is we're going to say, okay, let's take the 3x plus 4 to the other side, right? Which is probably not the nice thing to do. Let's take the minus 2y to the other side. If you take the minus 2y to the other side, you would have, actually, I'm very conflicted right now. I'm sorry, guys. I'm very conflicted. But anyway, let me do the one that is easy. So I'm taking the y to the minus 2y to the other side. So that's going to be 2y like that. And then what I can do is that I can divide by 2 both sides. And then what I'm going to have 3 over 2x plus 2 is equal to y, right? I'll write that nicely than that. So it's going to be what, 3 over 2x plus 2, right? Now that this is your equation number 3 and this is your equation number 4, Okay, so we've made a reasonable progress. So we've made these in terms of y. Now I'm not going to try to draw these functions. Maybe I will attempt to draw them later on, but not now. But now, what would the method do say now? And then says, once you've done that, equate your equations, right? This is number 2. Equate your equations, and this is where it comes from, the name of the method. Equate your equations. So basically, we said that y is equal to minus 1 over 3x plus 5 over 3. And we also said y is equal to 3 over 2x plus 2. So when they say equate, it means we say y is equal to y. And I'm going to repeat, that's why we use a g of x. Because this y is equal to y, it doesn't look nice, it doesn't look cute. So we do that. Plus 5 over 3. Yeah, that's equal to 3 over 2x plus 2. Now, we are in the right position, so you can try to solve this anyhow you know. Okay, so that's what we have, and yeah, you can think about what you want to multiply this equation by. I would multiply this equation by 6 throughout the whole entire thing by 6. If I multiply this by 6, so 1 over 3x plus 5 over 3 is equal to 3 over 2x plus 2. I'll multiply it by 6. Let's see. I'll multiply that by 6, that by 6, that by 6, and that by 6. And what I'll actually have is the following. Here, I would, so here I would have minus 2x, right? And over here, I will just have plus 10. Is it? Okay, let me just check. I think I made a mistake somewhere. Guys, if you see where I could have made my mistake, please let me know. I can't see it now. Oh yeah, I can see it now. So you see, from this equation, I said I'm going to leave 3y, and I'm going to take x to the other side so that becomes negative. I'm going to take 5 to the other side so that it becomes negative. It should become negative, but it's not negative. It was positive, so I'm going to change to negative. That's why I just saw that my answer is not going to look nice. So we do make mistakes, guys. Very nice to realize that we do make mistakes. So you're allowed to make mistakes, 100%. So I'm basically just changing all the minuses. All the minuses. There is all the plus to the minuses. So that would be minus. Okay, I'll try to. Okay. So now what do we have? We now have minus 10. That's now equal to that 9x and plus 12. Right, so definitely I can solve for x here. I can take this to the other side, take this to this side. This is going to be minus 11x. If I take that to the other side, it should be 22. So my x would be, so if I divide both sides, my x would be minus 2. My x is minus 2. What would be my y? So I can substitute my y anywhere. So you found the value of x. Number 3, substitute the value you got to any equation, right? And I mean it when I say to any equation. You want to substitute it to the y, to number 3 or number 4, it doesn't matter. I'm going to substitute it to number 4. Right, let's go ahead, substitute number 4. That was y is equal to, number 4 was 3 over 2x plus 2. That's what it was.